So welcome back. We're doing a couple more examples here today where we're looking at integrating in terms of the chain rule. However, in the last video we looked at just finding the value in terms of just with the constant integration of C. This time we're going to work the entire rule and then find out what our integration of C is going to be. So let's have a look at a couple of examples got on the board here. dy dx is equal to the square root of 2x minus 7 dx. And we know that f of 8 is equal to 11. It wants us to find y equals f of x. Okay, so let's look at this first one. If we look at the first one, the first thing we have to do is we need to integrate and change this into its indice form. So 2x minus 7 to the half dx. We're now ready to start integrating. So if we integrate this, we end up with, let's put the half out first. Half 2x minus 7 to the 3 halves plus c all over 3 halves. Alright, so let's tidy this up a little bit more. If we bring this up, we end up getting 2 times 1 over 2 times 3, which is 1 over 6, 2 over 6, which I could simplify down to 1/3. 2x minus 7 to 3 over 2 plus c. So, at this instance here, we've got our function in terms of the constant of integration. We can find that constant of integration now because we've been given an x value and a y value. So, when x is equal to 8, y equals 11. Let's plug that in. So we would have 1/3, 2 times 8 minus 7, 3 halves plus c is equal to 11. Let's tidy this up here. We get 1/3, 2 times 8 is 16, so 9 to the power of 3 halves plus c equals 11. I know that 3 halves is going to give me 27. So 1/3 times 27 plus c equals 11. So therefore, 1/3 times 27 is 9 plus c is equal to 11. So therefore, c is equal to 2. And now I can write my final statement in terms of y equals fx. So therefore, y is now equal to 1/3 2x minus 7 to the power of 3 halves plus 2. And this is my final answer. I've found out what my integral is in terms of the constant of integration. I then plug in my x and y to help me work out my c, continue it through, and get my question I'm looking for at the end, or my answer. Alright. So, let's have a look at the second example. The second example, hopefully if you've read it already, you know you need to integrate it from the language that's given to you. So it's saying, find an expression for y, given that dy dx, 1 minus e to the power of x, 2, and that the graph has a y-intercept of 4. So, let's have a look at this. How do I know I need to integrate this? I know I need to integrate it because it's saying we want a value for y. We have dy dx, so that means we're reversing this. So, let's reverse this. 1 minus e x to the power of 2 dx. Now in this type of question here, we have a bit of an issue. We really can't use this integral in this instance here because it's not going to give us what we need. What we will have to do is we're going to have to use a perfect square rule to get this integral out. So before we can do that, let's apply this perfect square rule. So we have 1 minus e to the x plus e to the power of 2x dx. Now we're at a point where we can actually start integrating. So let's integrate this function. We get x minus 2e to the x, because this would just be 1 times 1, which gives you that negative, plus half e to 2x plus c. So we've worked out this answer. Why did I not change this? Well, I didn't have to, because if this here is 1, then I get minus 1 over 1 times that negative 2e to the x. Well, 1 over 1 is going to give me 1, because it's negative, then that means that negative 1 times this, it stays the same. So I don't have to change that value. So I've got my integral in terms of this function. How am I going to find the c? Well, I'm going to find the c because I've got this information. It's saying that this here has a graph where it has a y-intercept of 4. So at some point on this graph, it's going to be crossing that y-axis at 4. So if something has a y-intercept of 4, it means its x-intercept would be 0. So similar to what we have for this last question here, instead of it having written out for us, it's telling us to actually pull that information out from what we know a graph looks like and how we find that y-intercept. So we can say here, when y equals 4, x equals 0. So 4, we get 0 minus 2e to the 0 plus half e 2 times the 0 plus c. Alright, so let's simplify this up. We get 4 is equal to, 0 doesn't exist, negative 2 times e to the 1. So let's have a look at that. Okay. That then gives me negative 2 plus half, because e to the power of 2 times 0 is 1 plus c. If we tidy this up here, we get 4 is equal to negative 3 halves plus c. So therefore, we'll finish this up down here. C is equal to 5.5, or we can write it as 11 over 2. So our final answer, so therefore, y would equal x minus 2ex plus half e 2x plus 11 over 2. A little bit longer than we had in the previous example, but when it comes to exponentials, that happens a lot. So what do we need to remember when it comes to these types of questions? We always need to remember that whenever we've got a kind of chain rule question, we bring out what our constant, our coefficient of x is out the front as 1 over that coefficient. We also raise our power by 1 and then divide by that power. Same thing applies when it comes to exponentials. Whatever our a value is, or our coefficient of x, 1 over a, everything else written the same. Cosine and sine, remember whatever the coefficient of a is, write it out the front, 1 over a, but remember you have to find the integral of that trig sign. And when it comes to finding your coefficient of integration, remember, sometimes they might be straightforward like this, where they give you the x and the y. Other times, it's implied. It's implied we have to integrate because it says for y. It's implied that x is equal to 0 because we have a y-intercept of 4. Really important stuff, really fun stuff, guys. I hope you really enjoy it. I'll see you in the next video.